Now that we kind of know how to recognize whether an experiment is binomial or not, now we'll look at the mean and standard deviation of a binomial random variable. We're ready to talk about, the mean and the standard deviation. We'll use technology to help us calculate these values, since using the formulas by hand is outside the scope of this introductory course. If you take more statistics in the future for your major, then you might see that where you calculate by hand, but in this one we'll just assume that a program or a computer or a calculator is going to do it for us. So first, let's look at this example where we're talking about blood type B and the mean. Overall, the proportion of people with blood type B is 0.1, so 1 out of 10, or 10 out of 100 people. In other words, roughly 10% of the population has blood type B. Suppose we sample 120 people at random. On average, how many would you expect to have blood type B? So that we can calculate by just multiplying that decimal probability by the number of people. So probability of that multiplied by the number of people that we're interested in will be 0.1 multiplied by 120. So it'll be 12. This suggests the general formula for finding the mean of a random variable. So my claim is that if x, the capital X, is binomial with parameters n and p, n being the number of trials I'm doing, in this case it was the number of people I'm sampling at random, and p being the probability of them having a certain trait, which was 0.1 in this case, that the mean of that binomial experiment is n times p multiplied by p. That would be an important thing to write down probably for these notes. Although the formula for mean is quite intuitive, it's not at all obvious what the standard deviation should be. It turns out that if x is binomial with parameters n and p, then the standard deviation for a binomial random variable x, capital X, is, so that this symbol here just represents standard deviation of this certain binomial random variable. It's the square root of np times 1 minus p. Yeah, that's not intuitive. Like above we saw that I already knew if the probability of each person having blood type B is 0.1, and I want to know how many of 120 people can I expect, I just knew to multiply them, so the mean was pretty simple. But this I wouldn't know. That's, like it said, kind of something outside the scope of this class. Just probably important to write that down. So example, suppose we sample the 120 people we mentioned above at random. The number with blood type B should be about 12, give or take how many. So what's the standard deviation here? In other words, what is the standard deviation of the number x who have blood type B? So we can do this calculation here. Let's see. The square root of n was 120 multiplied by probability, because there's, we've got n down, that's 120. Now we'll look at probability. We'll put that here. They said that was 0.1 multiplied by 1 minus the probability. Still p, so same p. There are two p's in this little formula here, two p's in a pod. Take that square root. We'll multiply all those together. 120 times 0.1, these two together make 12, multiplied by 1 minus 0.1 is 0.9. If I multiply those together, 12 times 0.9 is 10.8. I need to take that square root, and that, just use a calculator for that, or some web page that can do that calculation. It's about 3.3. So in a random sample of 120 people, we should expect that there would be 12 with blood type B, give or take about 3.3.